Okay, today we're going to talk about vectors, which are the motion and direction of a particle. Now, this is quite a long lesson, but I don't want it to be too long a video, so I'm not going to go too in depth. It's just going to be the basics of vectors. Now, I should say that vectors have two components, the x and the y. It also has three main equations, the position, velocity, and acceleration. Now, position is represented by x of t and y of t. Now, these should be treated as two separate functions all the time. It can also be written as x of t I, this I thing, with an arrow overhead, plus y of t, and this should look more like a j. So y of t, j arrow. I'm not quite sure what those represent. It's not really necessary. So velocity is the same, except instead of x of t, you have x prime of t, and instead of y of t, you have y prime of t. And as I said, you're not finding the derivative of this entire function or this entire interval, whatever you may call it. You're just finding each individual derivative for each individual function. And acceleration is x double prime of t and y double prime of t. So these are some of the more complex equations. Speed is defined as the square root of x prime of t squared plus y prime of t squared. Now, the reason behind this is speed, of course, in this sense, let's say this is y prime and this is x prime. X and y both representing positions. So the position of displacement, which would be x and y, is x prime and y prime. And so that's why we use those values in this equation. And you can see this looks awfully similar to the Pythagorean theorem. So if we have, for instance, a y prime value here, and an x prime value here, what we're trying to do is we're trying to just find the magnitude of these two added together, and not necessarily added together, but put together. And in order to do so, we could just find this line here, which also represents or is equal to this line here, which is what we're really trying to find. And we can do so by using the Pythagorean theorem, except instead of position, we're using velocity. So that's how to find speed. Now, distance is a bit different. It's essentially just the integral of speed. And this makes sense, of course, because position is velocity is the derivative of position. So naturally, speed would be the derivative of distance. Now, displacement is a bit different. You're just finding the total x values and the total y values, as opposed to the total x and y put together. These two over here are a bit more obscure. You may not come across these. Magnitude is just x squared plus y squared, or the square root of x squared plus y squared. It's really, again, you're just putting the two x and y values together. Direction is theta equals arctangent y over x, and this, of course, is just because that's simply how triangles work. It's not really necessary to memorize, because you can probably derive this on your own using SOHCAHTOA. Okay, so this is example problem 1. We are told that there's the position of a particle can be represented by 3 t squared as the x component and 3 cosine t as the y component at any time t. So let's try to find the velocity, acceleration, and speed of the particle at t equals 1. So let's first find velocity in terms of t. And that, of course, is just the derivative of the x component and the derivative of the y component. The x component originally is 3t squared, so the derivative of that is 6t. The derivative of 3 cosine t is 3 sine t. And so that's our velocity for this particle. Now let's find the acceleration, which can of course, be represented by the derivative of the velocity. So that's going to be 6 negative 3 cosine t. Okay, let's try to find the velocity at t equals 1. This is pretty simple. We just plug in 1 for t, so we end up with 6 minus 3 sine 1. I'm not going to pull out a calculator. This is fine for now. The acceleration at t equals 1 can be represented by 6 negative 3 cosine 1. Okay, now we just have to find the speed. Now, the speed, of course, is equal to the square root of the velocity, or sorry, the x component of the velocity squared plus the y component of the velocity squared. So let's plug that in. This ends up being equal to 36t squared, or the derivative of 36t squared, plus 9 sine of t squared. Yeah, okay. Now from here, let's just plug in 1. Now I don't really want to simplify this. We'll just plug in, like I said, 1, and we won't really simplify. So 36 plus 9 sine squared of t, or sine squared of 1, is our final answer. Okay, this is example problem 2. We're told that, okay, I messed this up. We're told that there is a particle with position represented by 1/3 t cubed minus 36t, 1/2 t squared plus 6t. And we want to find the time at which it is at rest. So in order for it to be at rest, both the x component, sorry, the velocity in the x direction and the velocity in the y direction must be equal to 0. Because if you have, let's say just x prime is equal to 0, it could still be moving in the y direction. And if that were the case, then it would obviously not be at rest. So let's start off by finding the velocity. Let's find the x component of that first, which would be t squared minus 36. Now let's find the y component, which is t plus 6. So as I said earlier, the x component and the y component must be equal to 0. So let's set t squared equal to 0. And let's set this equal to 0 as well. Okay, so we can already see that the only time at which the y direction, the velocity of the y direction is at 0 is at t equals -6. Let's try to find it over here. We end up with plus or minus 6 because we just simply take the square root. So in the x direction, the velocity is equal to 0 at -6 or +6. In the y, it is equal to 0 at only -6. So obviously it can't be +6 because, as I said earlier, both the x and the y direction, their velocity must be equal to 0. And since they both are equal to 0 at t equals -6, that's the only time it is at rest. So that's our final answer. This is going to be our final practice problem. We're actually going to try to find the total distance traveled by a particle with positions, with x position 2e to the power of t and y position cosine t. We're going to find that from 0 to 1. So as you know, let's just say total distance is d. D is equal to b, the integral from a to b, the square root of x prime t squared plus y prime t squared. So let's try to just fill these in. Obviously, b is going to be 1, a is going to be 0. X prime of t is going to be equal to t, or sorry, it's just going to be equal to et, because we're differentiating with respect to t. And y prime of t is going to be equal to negative sine of t. Now, I don't really feel like actually simplifying this, because obviously it's going to require a calculator. So let's just do this to the best of our ability. Let's say the total distance represented by d is equal to the integral from 0 to 1, the square root of 4 e t squared plus sine prime of t. And that is our final answer. Well, not final. It could be simplified more, but this is good for now.